So our other case here is an ambiguous case, where if we have two sides and an angle, that is a side-side angle triangle, not an angle side-side triangle, unfortunately for, well, some of you, I guess. But when we have an arrangement like that, it means that we have the angle is adjacent to one of the sides we know and opposite of the other. Where, unfortunately, this isn't a case with guaranteed behavior. If we have that the side opposite, which we'll call small a, of the angle big A, if that side length A is the same as the altitude or height h, then we form a right triangle. And we're back in chapters 4 and 5. And we don't have a whole lot of new and interesting things to do because we know right triangles pretty well at this point. Alternatively, if we have that the length A is bigger than either of the known side B or the altitude h, well, in that case, we get an oblique triangle. And we may have things we can do with that, depending on exactly how it's set up. On the other hand, if we have that if A is less than B but greater than h, we'll get two triangles, sort of two, and we'll have that it acts a bit like altitude, but not quite in the same way because it's too long and kind of bends a bit. Or if we have that A is smaller than both B and H, then we sort of just form like a fishhook shape. And that's not a triangle because the side length is too short. We have to squish down that angle A a fair amount to make it work. But the point is, if all we know are two sides and an angle, we're not really guaranteed any information about the overall triangle, if it even is a triangle. And to understand this, we're going to look at a couple of examples here.